we have enough K2S to make 4.16 grams of Fe2S3. So how much can we truly make?
$4.16 grams.
Good. Both at home and here, both said 4.16 grams. We can only make the least amount. We don't have enough K2S to make 5.20 grams because we only have enough K2S to make 4.16 grams, right? Just like if you were making chocolate chip cookies, you may only have enough chocolate chips to make one batch. Even though you want 3 batches, you can only make 1 batch because you don't have enough chocolate chips. So that is called the limiting reagent. The K2S is the limiting reagent. The theoretical yield is what the math tells you you can make. We could theoretically make 4.16 grams of this. Sometimes you don't get that though. So if we take a look down here, a chemist sets up a chemical reaction. According to his calculations, the reaction should produce 2.33. So that's his theoretical. Instead, he gets in the laboratory, and we're going to see this tomorrow as some people get into the laboratory. Instead, he only makes this amount. So you take the experimental, divide it by the theoretical, and times it by 100, and that gives you what you call your percent yield. So there's our experimental. Here is our theoretical, and we times that by 100. 1.54 divided by 2.33 times 100.
The answer is about 66.0944.
So you only had about 66% yield. 66% yield. Let's try one more and then we'll talk about the laboratory. This one is on page 7. So we have a new equation. This is the combustion of octane. So it says how many moles of CO can be produced by starting with 25 grams. Now, I went back and regraded all the late submissions for the mole homework. Some of you guys still don't realize whatever they give you should be the thing that you start with right here. You just start with that right there. And then you go. Where do you go? You go to what they want you to get, which is that. It's up to you to figure out how you get there. The easiest way is to put whatever's here on bottom of the next step. Grams of C8H18. Well, what can I get from grams of C8H18? I can get moles, because there is this thing called the molar mass. And it is the mass of 1 mole. 8 times 12.01 plus 18 times 1.01.
It's 114.26.
I got that number from the periodic table, 12.01 for every carbon and 1.01 for every hydrogen. Now remember, the only time I can go from C8H18 to CO is with the balanced equation. Every 2 moles of C8H18 can make 16 moles of CO. And that gets me to moles of CO, which is what I want. 25 divided by 114.26 times 16 divided by 2.
It's about 1.7503.
1.75 or 1.8 moles of CO. 1.8 moles of CO. Now, I'm going to check if I have 25 grams of oxygen. How many moles of CO can I make? So basically, I'm mixing 25 grams of octane with 25 grams of oxygen. Now, it's 32 grams of oxygen equal to 1 mole of oxygen. Again, periodic table. For every 17 moles of oxygen, we make 16 moles of carbon monoxide. That's what I want, moles of CO. 25 divided by 32 times 16 divided by 17.
The answer is about 0.7352.
So 0.74 moles of CO. Out of these two amounts circled, how much could I actually make? Anybody at home? Out of these two amounts circled, how much could I actually make? Can I make 1.8 moles of CO? Whenever 25 grams can only make 0.74 moles? I can't. I can't make that much because I don't have enough O2. There we go. Cool. You are to finish up this packet for this evening. Let's take a quick look at the laboratory. So it says the mole is the common language in chemical reactions. The mole is a convenient unit for analyzing chemical reactions. The mole is equal to 6.02 times 10 to the 23rd atoms, or Avogadro's number. The molar mass, found from the periodic table, is the mass of any substance. It's a mass of everything represented in the formula expressed in grams. In this experiment, you will observe the reaction of a measured mass of magnesium with an excess of hydrochloric acid. So that means the magnesium is a limiting reactant. The hydrochloric acid will be evaporated and the mass of the product will be measured. This data will be used to collect the formula of the compound processed. Well, if we're taking magnesium and we are reacting it with hydrochloric acid, what type of reaction is this? Magnesium plus hydrochloric acid. What type of reaction would this be?
Single displacement.
Single displacement is correct. It's the only one where we have an element and a compound. So magnesium is going to come in and replace hydrogen. Anytime we make something new, we've got to check the charges. What's the charge of magnesium? Very good, +2. And the charge of chlorine? -1. So this means that what do we need here? We have 2 positive and 1 negative. So how do we adjust this formula? Another chlorine instead. We need 2 of the chlorines, MgCl2. So that's magnesium chloride. Anybody see anything else wrong with the way I've written this? Said in class here that hydrogen is diatomic, which is 100% correct. So I need a 2 there. Anything else we need to do to this formula? That is correct. We need to put a 2 in front of, I said it. I did it, but I did it wrong. We need to put a 2 in front of the HCl. There we go. So, those of you that are coming to class tomorrow, Jeremy, are you paying attention to me or what are you doing? You playing Pac-Man? I'm trying to help you out here. So those of you coming to class tomorrow will be performing this laboratory and then other people can watch you. So you'll need to know a beaker. A beaker is basically like a cup. If you've never seen one before. You need to measure the mass of the beaker. So we'll be using the scale tomorrow as well. You're going to put a piece of magnesium into the beaker and record the mass of the beaker and the magnesium. What that will do is if you have the mass of the empty beaker and you have the mass of the beaker and the magnesium, you can subtract those and find the mass of the magnesium. Then you're slowly going to add HCl. It's quite concentrated HCl, so you're going to want to be careful. Slowly going to add that. And then you're going to record any observations that take place. You're going to keep adding 10 milliliters until all of the fizzing stops, or you get up to 50. Then you're going to place the beaker on the hot plate, and you're going to boil off all the moisture. The hydrogen is the fizzing part, right? Since it's HCl, that's aqueous, so we've got a bunch of water we need to boil off. Once we boil everything off, we should just be left with this product. So then again, you will carefully, you don't want to touch the beaker because it'll put fingerprints on it. Carefully using a paper towel or something, you will put the beaker and the product onto the scale. Then you will record the mass of the beaker and the product. Since we previously have the mass of the beaker, we should be able to find the mass of the product from that. Right? Because the mass of the beaker plus the magnesium minus the mass of the beaker will get us the mass of the magnesium. It says on the question 2, calculate the mass, that's how you do it, and the moles. Well, we've done a lot of moles by this point. We look up at the periodic table and find the molar mass of magnesium to be 24.31. The mass of the magnesium divided by 24.31 times 1 gives us moles of magnesium. What is the mass of the product? Well, we will do the same thing we did here except for the product. Then notice here it says subtract the mass of the magnesium from the mass of the product. That is the mass of, well, if we have MgCl2 minus Mg, we are left with just Cl. That's the mass of the Cl. Well, again, we can use the same thing to find the moles of the Cl. Then you calculate the ratio of the grams. Then you calculate the ratio of the moles. Basically, you divide each of those by the smallest number, right? That's how you make a ratio. Are they the same or different? Based off the mole ratio, what is the formula of the product? Is that what you expected to see or not? So we're hoping to see a ratio of 1 to 2, right? That's what I'm hoping to see. Then it says calculate the molar mass of the product and the percent mass by composition of each sub-element. And you have that mass. You have the mass of the total. And you have the mass of the magnesium and the mass of the chlorine. So you should be able to find the percent mass of your substance. And using the molar mass, you should be able to find the percent mass of the, what we would call the actual or given from the true formula. And then you will subtract actual minus experimental divided by actual, and you will find the percent error that you get based on the percent composition of magnesium. That's what we got. So you can choose today to either do some credit recovery stuff if you need to, finish up this packet on the moles, or if you're all done and you're ready to work ahead, then you can start that laboratory with the video, but that's unfortunate because you won't be able to watch somebody do it live. So much more fun to watch somebody do it live. Question, Christian?
Yeah, can you open up a test for me today? The one I got an 82 out of the 9 weeks one.
Yeah, I can do that.
Okay.
Anybody else have any questions? All right then. Nice job, William. Very nice job on that. I just saw that. And Laura, nice job, Laura.